In this video, we're going to look at topic 84, example 4, graph the reciprocal function. So we're asked, how do you graph the reciprocal function y equals 1 over x? The reciprocal function maps every non-zero real number to its reciprocal. All right, so let's start with step 1. A lot of this is already listed for us. We're just going to work through it. So consider the domain and the range of the function. So let's start with the domain. Well, we need to look at our function y equals 1 over x, and we need to ask ourselves, are there any limitations to what x can be? Well, we have x in the denominator. We know that when the denominator is 0, our function is undefined. So for our domain, what we can say is that the domain is x for all of x, where x is not equal to 0. This is a fancy way of saying it. We can also use interval notation, or we could just say in general something like x cannot equal 0. Right now, let's just grasp the fact that x cannot be 0. Let's not focus too much on how we're writing the range or the domain. Now, the range are the y values. We need to try to figure out what y can or cannot be. Well, y can pretty much be anything when we're dividing 1 by a number. All right, it is possible to make the numbers larger or smaller. However, no matter what we do in terms of x, y is never going to be equal to 0. We can't do 1 divided by a number and get an answer of 0. So y, again, is for all real numbers, where y is not equal to 0. You can just say y cannot be equal to 0 for now. Okay. Don't overthink this. We'll get into more specifics and you'll start to understand it as we go through this example and the following one. In step 2, they want us to graph the function. I'm going to use the calculator to do parts of this, but this is kind of intuitive. You can figure it out. Let's say that you just took x to be 1. Well, 1 over 1, so if I plug in, if I say x is equal to 1, then 1 over 1 is 1. So I would have a point here. If I plugged in negative 1, I would have negative 1, right? Because 1 divided by negative 1. I can't use 0. If I plug in a 2, 1 divided by 2 is 0.5, so I'd have a point like this. Now, maybe that makes sense to you, maybe it doesn't. Let's go to our calculator and let's type in 1 divided by x as our graph. If you look at the graph, it's going to look something like this. We'll get into some more specifics in a moment. But let's say I go to my table. So at 0, it says there's an error, which makes sense because we said that x cannot be equal to 0. That's going to be undefined. So at 1, we get 1, 2 is 0.5, 3 is 0.3. So that's going to get closer and closer to the x-axis. 4 is 0.25, so that's going to be even closer. And what you'll notice is that you're going to have a curve here that gets closer and closer to the x-axis, but never actually touches it. Let's look at the negative side of this. Negative 1, negative 2 matches up with negative 0.5. So you actually have kind of the mirrored version of this here, and you're going to have something that looks like this, and it'll get closer and closer to the x-axis. But these numbers, your y values, get smaller and smaller, but they never actually touch 0. Or sorry, not necessarily smaller and smaller. They get closer and closer to 0, yeah. Now, it's tough to see what happens between 0 and 1 on our chart, but if you look at your graph, what's going to happen is this is going to go up here, and it's going to get closer and closer to the y-axis. And on the bottom half, it's going to go down and get closer and closer to the y-axis. Your x and your y-axis axes are never actually touched by your graph. So it's going to get really, really close to them, but they'll never make contact and it'll never cross that. That's where step 3 comes into play. We're told to observe the graph of y equals 1 over x as it approaches positive infinity and negative infinity. So that's telling us when we look this way and this way. Well, what happens here is we have this statement here where an asymptote is a line that a graph approaches. Asymptotes guide the end behavior of a function. So as x does approach infinity, so as x is going to the right, f of x approaches 0. So your y values start to get really close to 0. And the same is true as x approaches negative infinity, so going left. The y values get closer and closer to 0. So the line y equals 0 is what's called a horizontal asymptote. All right, and that would look, just going to put a dotted line here to represent that. Okay, so this horizontal asymptote. An asymptote, think of it as a boundary. Now, most graphs don't cross that boundary. It is possible, but what the horizontal asymptotes do is that they tell you that the graph will approach that. Okay, whether it's from above or below, your values are going to approach the asymptote. That's for your horizontal asymptote. Step 4, we want to look for the, observe the graph of y equals 1 over x as x approaches 0 for positive and negative x values. So as we're going closer and closer to the y-axis, so as x is getting closer and closer to 0, what's going to happen is that y is going to approach positive infinity and negative infinity. So let's get rid of that there. You have what's called a vertical asymptote. So it's never actually going to cross the y-axis. So here, down at the bottom, for negative values of x, as x approaches 0, f of x approaches negative infinity. The domain of the function excludes 0. We already stated that. So the graph will never touch the line x equals 0. X equals 0 is your y-axis. So the line x equals 0, or your y-axis, turns out to be a vertical asymptote. That's kind of it. I know that may or may not make sense to start. You'll get some practice with this. Think of the asymptotes as boundaries that your graph is going to approach. Okay. It is possible to cross a horizontal asymptote, but it'll always approach it from either the top or the bottom. It is not possible to cross a vertical asymptote. Okay, so kind of keep that in mind. The other thing you want to remember here is what your reciprocal function looks like. You're going to have these two curves. They're going to be kind of diagonal from one another. You'll have the bottom left and the top right. Or if your graph was reflected, you would have the bottom right and the top left. Okay. We will get into more detail with the next example, and that'll be a little bit more of the practice problems that you'll see moving forward.